Ladies and gentlemen, Mason is here, and today we are going to be putting together, first cleaning up the parts for the stepper air screw. This is the stepper, and these are the legs, the rails. We'll clean up the new parts that are here, and the carriage and all these. First, clean the debris off, then going to put the whole thing together. Hopefully it will be nice and no parts will need to be how do you say this, iterated, but maybe, so I do not know. So the point of the whole thing is that we want to add this potentiometer to the carriage itself, so as the carriage moves up and down, it moves this with itself, and it is connected to the carriage with a screw or fixed to it, and as the carriage moves this up and down, basically we get the position feedback from it, so that we know exactly where the position of the stepper is in terms of the needle valve. Yes, and we will have to add some MX code and some wiring to it, but I think it will be fine. Probably we need to clean the wiring up on the board itself, because now the if it is visible, this little guy here, which is the stepper motor controller board, has been made on this breadboard, on the solderable breadboard, and basically the other breadboard, which is just a plug-in, that's all, will be needed to be replaced, and the wires will need to be disconnected. So that will take some time, but yeah, let's jump right into it. In the beginning it will not be the most interesting, but as I am getting ready with the cleanup, it will be maybe getting a bit more interesting. We'll first dig myself this box that I collect the filament chips into, this garbage box that I have here, and I'm just going to clean up the parts. Nothing spectacular first, but I suppose everything is kind of boring if you do it. Alright. The trustworthy knife. Thought I was already bleeding, but no, haven't even started. garbage bag, garbage box to be honest, to be more precise. Putting on, this is the top actually, so it is the other way around. would fit. It's a bit wobbly, but I suspected it would be like this. I could have ordered it. Oh, I couldn't. I could have ordered the maybe it's on the other way around. I can put this aside now. So this leg is instead of this one. Pretty solid. can eat for that. I think this will be alright. Now the only question remains that to take out the where is the tool? There's like a hole there for it, meaning the bit is supposed to be somewhere around here. Alright. I hope I did not take it away. Not good. We have this is 30, right? This is too big. Can't use B for jack shit. Maybe have to check around. Can't remember where I put it, but yes, it's here. Alright, so what I need to do is to use the drill to take out the, basically, as you can see, I'll zoom in. This little fucker got cracked. There's like, as you can see, that there is like a crack in there. Needs to be completely thrown out of the trash. Unlucky. Minus like a 600 watts, or like not 6 but like 100 watts. It's the other way around. Or am I not putting it on right? So if we have this here, it's not gonna be okay, right? Because we need to have it here. Or here. We need it here. Yes, we need it here, but supposed to be from the bottom. Yes. Yes, I think it will be okay. Or will it? If this is here, we need to have it this here. Yes. Yes. We need this towards that side. So how much can I zoom? This is the inside and needs to be pointing that way. It does matter which direction you put it toward a bit. Basically now we put the screw in. Screw in! this is the max it can go up, because it sits under here. Great, love it. Now we can put this shit in here, exactly where it's supposed to be, and then how the fuck are we going to do this? Because this will be needed to be connected to the carriage, but how? Mr. Carriage. This doesn't look too straight, to be honest. We hope the shit makes it a bit wider, so the carriage can slide up and down. We'll need to remove these so that we can put on the carriage, and maybe we will need to take out this so that I could drill. I can't drill from that either. It's a bit difficult to see, honestly. So basically they put these here, but we cannot because the thing is too low, so we need to take these out, take this screw out and put it there, and then put the hole onto this shit, or at least mark it up so that we can, at least we mark it up, and then we can put the thread into the middle. We'll need to clean the thread as well. This is fine for now. We need to take these two legs out. Not too convincing. Oh, it looks like it has a crack, but yeah, it didn't. Or at least I hope so. Great. Please stay where you are. Good. Because now it will not go on it. Oh. Fuck. From the top it goes in, but the hole is too small. Then I need to clean the gap. hope it will be okay. Need to check. We'll need to cut down from the edges. Yeah, this doesn't look too nice. Yeah, not the best, I'd say. Quite tight. This is kind of shitty. Take off from the rear. Oh, this is not cleaned properly. Great, good to know. Cleaning down the garbage junk from the rail itself so that the carriage will slide just like, I don't know, very smoothly on it, I would say. That's the point. So this is the carriage and this is the rail or the leg. I mean, it's a bit better to be honest, but not too much. I mean, this will do. I think this will do. It's a bit sticky. I will wear them out. And this would be better a lot like yeah, by a lot. I mean, oh, actually it slides like this. So we'll add a bit of grease to it maybe, or a bit of have like a bit of lithium grease or some shit. I need to take care of the other one. Take good care of this, because this currently does not really fit the mold. It does like have some debris on it. So I'm not going to put it in. That's what she said. I mean, yeah. Oh, the music is still going. Miss the favorite music. Dun, 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 dun. Dun, 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 dun. Dun. pause for a little bit because I feel my tendons are working. I will take a bit of break, like a 5 minute or so break, and then come back stronger. Using Droid Cam. Yes, indeed. So clogged. Kinda sticky. Sticks. Fiddle sticks. We'll need to clean the, how do you call this? Is this a fucking joke? The print isn't coming off. Hooray. Continue cleaning. What an experience. Give me some music at least. Oh, oh fuck, this is muted. Well. Doesn't really matter that much. are punished after death. Ex Inferno. Wicked are punished after death. Oh, so basically removing the filler or the support from the thread itself. Maybe I should have not used the support material, although it helps a lot with the thread, to be honest. So oh, my back. To the void. Let's see. It's the other way around, by the way. Put them in the trash. Pretty good. I mean, it doesn't really matter because the to clean out the hole. Nope, I need to make this let's see if it makes the way. Yeah. To clean out the hole, then we'll put a little mark in it. I'm going to drive the screw into it. Hopefully it will not break this shit. Oh. autonomous. Fuck me, something, I don't know. No, I don't think it went into my eye, but it is very itchy. I do not know how far this shit is. What is the question? Where is this shit? Oh. Need to put it together, then I can mark it. Fine. Stepper is heavy as dirt. So need to put this shit on here, but I will unthread the or push it inwards. A bit. Still a bit too much. So basically this will be like so. Uh-oh. I feel that there is going to be a bit of a problem here. There is definitely some problems here. Oh, I did not calculate but how? I did not calculate the fucking. Oh, I need to remake this. I need to remake the fucking carriage because I did not calculate out the inner. Because as I downscaled the carriage. Fuck the. Yeah, should have been 52 for fuck's sake. It downscaled that too, so it basically is tapered downwards rather than. And this 2 millimeters is the fucking. Have to print out a new carriage. Great. Regardless, remove the legs and what can we do? I mean, technically we can put the things on. So basically this comes in here. This is the pot. Why the fuck does it zoom out then? Sorry. Poor cameraman. So basically we have the pot meter here with this little lever shit that basically it does going the pot meter on and off and adjusts the resistance in it, and with that we can basically have a feedback, and we will have to put this onto here. So as I will have to mark it out because it's in the line. Maybe I should heat it up. Maybe. So we'll heat up the nice coke. So getting hot in this little pullover. I'm gonna remove this from myself. Great. Where are we? Here. So I need to, technically we could trash everywhere. Whatever, so we have removed that little notch. There is no light. Need that little notch there, here, so that the potmeter's leg will not interfere, because currently the leg is in the way. Hopefully this way it will. No, great. Perfect. Perfect. Yeah, perfect. So great. We need the leg. We need the leg, or the pot in itself. Fura, sározok. Little bit of dent on the other side, but I didn't. Maybe not the best in terms of stability, but I'd say it is pretty solid. It is a bit wiggly woggly, but that's probably because here the gap is not completely on it. But as you can see, the lever can be moved pretty well. Maybe it's a bit wanky, but I'd say it will do. We would need to print the carriage. I mean, first we need to remake the carriage because this carriage is fucked. Oh god, fucking damn it. Also my hands tendons will be fucked as well. Again. Not the best choice. I suppose we will call it this the day. I think I will put the carriage, I will design the carriage, then I will what do we call it? Put the carriage together, then solid it's launch this bullshit. We are going to I'm going to call it the night. I'm going to eat then read the last pretty great fun, to be honest. Technically, if I could, like, so yeah, in the last few days, cheers, been getting more onto reading at the end of the day, like 1 hour. I usually read The Dune by Frank Herbert. Yeah, it's a great, like, how do you say this, complementary read after watching the movie. I thought, when, like, after watching the movie there is nothing to be in it, but I then realized that the main point of the whole thing is that it has extra content, so is the movie, like, how do you say this, extended. Carriage. We need a bigger gap in the thing. Facade. Yeah, what I did not consider is the fact that if we calculate the (51) times 0.95 is 48. That's not too good. So we should divide the 51 by 95 and times that by 100, and we will get 53.68. And we will give it 54 because this bitch gets smaller than it should be. So wait a minute, where are the legs? So this is a bit tight. We need to still skim this more. But the interesting thing is that this is not wide enough. But why? So if we have this, and why would it be so tight? Because not the inside, the outside is the problematic part. And the outside is the problem, not the inside. As well as, like, so how do you put this in? So basically, if I have the one like here correctly integrated onto the shit and threading the screw back so it doesn't fuck with me, also maybe pulling the leg out a bit. If I could, it would not stick to the self. Would not stick to thyself. I'll remove this threaded fucker. Maybe we should lower it back so that we have at least this leg is too tight, for fuck's sake. Yes. Either, yeah, the outside is not wide enough, so it's not far enough. It's not far enough. The outside is not far enough. That's the problem. fine. So the outside is the problem, not the inside. Though I think that so this should be bigger. How much? Oh, fuck, I should have measured. Not good. No. 77, but it will be downscaled. So 77 is the distance, I think, but need to measure it. That's the distance, but 77, perhaps 77, but the 77, but when we times that by or divide that by 95, 0.95, that is 81 millimeters from each other. So the inside is not the problem, the outside is the problem. So we should move the whole thing, yeah, we should move the whole thing. So it should be, how much? Where the fuck is the, oh no way, I'm brain dead. So 80, or what is this, 77 divided by 0.95, 81. So 81, well, how much is that? 81 divided by 2, that's 40. $55, 81. Maybe we should give it a bit more. I really hope it will fit. I'm a bit annoyed. Maybe I will scale this up by a little bit. Scale. Let's go with one. This would be 50%, this is 5%. So I think this is fine. I think 5% is not going to do too much like problem. You'll need to what is that called? It's not that big of a deal. I think this is fine. Okay, save this bitch. Save again. STL, overwrite, yes. Could launch the printer. I will break the end of this shit. Close the eye. Not to get a shrapnel in there. Would not be too nice to go to the hospital at the evening before reading. Technically I would not read with that eye for probably quite some time. Getting the debris off of the bed. remainder of the brim, to be honest. I have this new printer bed top, or like hot end, or not hot end, hot plate, creates this texture, this rough texture. As you can see, this is the smooth texture, this is the rough version. It creates that because this has this rough thingy, but regardless it is good because it comes like off to print better, except when it is cold, but then you should usually remove it at like 40 degrees. That's good enough, because the hot end, when basically the print will be printed, it is like about 70 something degrees on the bed. I have fucked up already. So putting on the carriage, right, select it, scale it to 95% ish, maybe. Print via USB. So yeah, getting this shit done, printing the part, that's pretty good. The big secret sauce is going to be that, or not secret sauce, I mean it's pretty obvious, but this is the best part of it. So satisfying to just push and pull it down, so smooth. It will be very cool to have this shit. We'll have to check, because I have pushed this little plastic piece on here, and it didn't went all the way as I expected, but it basically, when you push it, it pushes the whole carriage down, so that's not too good. I don't want to, oh I don't want to break it. Yeah, I should have probably preheated it a bit so that it slides in better, but then it would, you know, shrink and then not be as tight. So I think this is better, because this way it is basically never going to come off, unless if I really force it to, but I think it will be rather just bend the whole thing or break down, but not come off. What I want to do is to heal the thing, potential, or the how do we call this, the resistance between two legs. So basically, if I am correct, this should be about 0. No, this is the 11,000. So this is the 11,000 completely down, 11,001, put it all the way up, it should be the 0. Okay, this is working. Thank God, I thought I fucking ruined it. Okay, so this is the working thing. This is basically just a constant 11,000. This isn't going up or down at all. So the first one is to have the, yeah. So this is the one, good one. The top one is the better one. Okay, good to know. Great. So the point of the whole thing is that, so I did not today. So the point of the whole thing is that well, okay, we have, where the fuck is it? I'm not going to like bring it up because this is heavy in itself. It's just like fucking 250 grams, or maybe 1/2 kilo. So basically what this does is that we have the how do we call it, the stepper, the air screw here. This is the no. So we have the air screw here. Like so. Can't see it. That there. Here is the spindle of the motor, and here is the spindle of the air screw. And basically what this does is that we have this thing here called the shaft, threaded shaft. Threaded shaft sits on here, and as we basically turn the shaft, that on the other side has the hole for the spindle for the needle valve, and as the whole thing turns, basically as the motor turns the needle valve, it adjusts itself. This has this threaded thing on it, so basically thread, and that allows the carriage to go up and down, to slide up and down on the other two legs, so to speak. This is a bit tight, so it will not slide, but you can imagine that the thing is spinning here, and it causing to when we are when we are closing the needle valve, then the carriage is going up. When we are opening it technically, so we're letting more air. So as we increase the tighten clockwise the needle valve, the pressure is going to build up, and so is the volumetric flow. And that, I mean, I can make myself bigger probably because I forgot to zoom out. So basically, as we are threading this, we increase the airspeed and the air volume and the pressure as well. But this on the other side, it goes up. But because we only had this little limit switch on the pin, it was not enough in itself, because when you home it out, then you know the position. You step it once, and that is going to create one error, because when you start, it will not immediately start, but jump and then go up, because of an effect called stick slip, which is basically that there is friction between the two materials, and when there is basically two types of friction. There is static friction and dynamic friction. Static friction is always greater of a force than the dynamic friction, and that is why starting things is far harder than pushing them. So if you have an object, when you start pushing it, the biggest force will be needed to push it to start to push it rather than to keep pushing it. This is the same thing with here, that it jumps, and basically there is a force needed for it, so basically it can move on. But when you do not, basically you start to apply the force, and then applying the force, and then it at the given when the force increases, at a certain point it is enough of a force that the friction is getting, like, so to speak, beaten, but like overpowered, and then it beats overpowers the friction, and thus moves against the friction on the basically in the direction of the greater force. But that is that we have a given amount of force, but we don't have force and with it movement. So why is this important? When you are turning this shit, you basically have already turned it, like, let's say, a quarter, when this starts to jump up, rather than it moves like, you know, linearly up, like as you turn it. So this will introduce this stick slip error, and but the main point of the whole analog or monologue is that when you click this on the beginning, you know the position exactly. But when you first move, that's one error. When you move the second, that's two errors. And if you move small increments, which we need to, because the uh, pressure needs to be adjusted very small. When we start off and we open the needle valve, we need to jump about 1500 ish, but at the above that we don't need to increase it that much to increase it significantly, so that there is like a basically like a very sharp increase in pressure. So it is kind of like this: we increase the movement, nothing, then it rises up in terms of pressure and volumetric flow. So that is why we need to step it fine, but that stepping fine will cause a lot of problem points, because we are going to step it a lot of times. That's going to add all these errors up, and all these errors added up are going to cause that we are not going to know where the carriage is, and basically the carriage in, like, also when I talk about where the carriage is, that what position of what position is the needle valve itself, because the carriage goes up, but the carriage sort of moves freely, unlike the the needle valve, because the needle valve and the motor is basically coupled together, kind of fixed, so to speak. So this is a hard coupling. This doesn't allow too much flex in terms of this is like called torsion flex, that basically when you take like a long rod and when you twist it here and you basically fold it here, then it might will have a little bit of torsion, meaning that it can twist and it will like twist a bit, and it's not going to be that much. It's probably under like 100%, or like 100% is too small, but 10%. So 1% is 10. So divide like 0.1%, or maybe even less. Who knows how much for Peggy. So the point is that when we use the hard coupling, and we move the carriage, the carriage can also wiggle a bit, because as you can see of the stick slip, as well as the other problem is that we have that's why I am printing it a bit smaller, and that is why this is not good, because the carriage itself needs to be a bit tighter than it is, and I can't downscale the fucking thread in solid edge, because it is not drawn out, it is put in there, so you cannot make it 12, because, or it's a M12 thread, but you cannot make it M11, because that's not going to go on it. So need to downscale the carriage so that it is tighter on the thread bed, because the thread itself is not like a very stable constraint. The constraint is the legs, but the legs also have a bit of wiggle and all that, and also the stick slip. So the carriage itself will not be the best. I mean, maybe it will not be absolutely perfect with the how to say this, with the feedback, but it is going to be a lot more like we are going to have basically feedback rather than just estimating and guessing based on like this is how the 3 printers are doing it, like mine, and the 3 is doing it, that you home once and then you move to a certain point and then you move to another point. You don't know where you are at the, or like basically you are calculating it from the previous steps. So let's say the stepper code is that move 200 forward. We are at 0, so the first command is 200, then we move 200. We know that at 200. So we need to move like let's say 50 back. So that we are at 150. And it's always calculated like this. So it is adding on and all that. It doesn't have feedback, so that's the point. It doesn't have feedback. This is called a feed forward. Then we just adding the numbers onto the current number, and we do not know what the actual data is. And that is why you need to have a very if you are using feed forward like this, you need to have a very good mathematical model that is basically that you know exactly what the actual value is going to be given at that, let's say, position. So if I put a, in this instance it would be probably like voltage or like turn, but probably wouldn't say voltage, probably like turn, so it would be like X, they call the twist, or like not X, phi or phi, the angle thing. So how much angle do we move, and based on the movement of the angle of the stepper motor, we will know that how much the carriage and the stepper is moving, or not the stepper, the carriage and the needle valve is moving. The needle valve should move the exact same as the thing, but the stepper, or no fuck, I'm getting confused. So not the stepper, but the carriage will move up and down. Might not be linear to that, but might be like some how do you say this, losses based on the friction and all that. So we need to compensate, and what the actual actuated value is like airflow. So how much phi, or like angle, difference angle, so basically as you turn it, let's say a quarter or turn, which is God knows how much radii, it is whatever, I can't remember how to calculate it. There is something to do with 180 and dividing it by pi or something like that, but I'm not going to try to do it. So the quarter of a turn, how much pressure increases is going to be, and again it is not going to be linear throughout the whole thing, because when you open the valve it shoots up straight and then it smooths out at some point, but probably you can put like a linear onto it if you really wanted to, or maybe a quadratic, or decaying quadratic, so it's a 1 by, or is it it's the, is it the 1 divided by x squared? I think that's the function that you want, so that is the, you know, curving up, and then it starts like this, kind of like an S, hysteresis or whatever they call it, diagram. So yeah, it's kind of like that. So the point was this, so that we know where, so we have like feedback where the pressure, or fuck, need to think better, my head is getting hot. So where the, based on the position of the carriage, we will know how much air and what pressure of air we are letting into the burner, so that we can know the, basically this will determine, maybe I will know because it is a bit complicated, there is a lot of steps. So the main thing is that we need this air for now, because we need to break up the fuel, and because the fuel is viscous, and will be even more viscous when we are using veggie oil. Now it is diesel, but that's probably pretty easy to break up. Veggie oil will be needed to be heated up, but probably then it will be easy as well, kind of like diesel, at the same viscosity, which is basically meaning that how much the droplets stick to themselves. So basically there is like internal friction between the molecules. So if you have high viscosity, like a tar or some shit, or like bitumen or asphalt, then that is basically like very, very, very high in viscosity. You need to heat that up to like 200 degrees C, so that you can have it so molten that it is kind of liquid runny, and then you can blast it into the chamber with the air and then split it up. Because this compressed air, what it does is that you have a tube, and you take it down, taper it down, and there is like an inner tube in it, and between the cone and the inner tube there is a bit of gap here, like a circle, like a ring, and through that the high pressure 2 bar, or about 2 bars of air, 1.7 bar is going to be, because I have a 2 bar pressure sensor that I want to use, so we'll reduce it to 1.7 bars. 1.7 bars of air is going to go outside there and going to expand to atmospheric pressure, It's going to cause it to speed up and to basically it is going to expand, so it's going to take up a bit more space, as well as like it is going to speed up because of that. So that is, as well as like the taper down helps as well, because when you taper down something it has to speed up so that it can go through the same zone. Basically when it goes through that little zone, that little, they call it annulus, it's a circle, it's a circle 2D in terms of like ring, and then it goes through that about 1 millimeter or half a millimeter thick of annulus. You can imagine that there is going to be like 50-70 meter per second of velocity there, which is kind of high. That is going to basically just split the fuel into not atoms, but like very small droplets. The central tube is the fuel carriage. The fuel comes in there and the annulus basically just concentrates next to it, and it basically is just going to create like a, I mean, you can even spin it, but it usually doesn't spin it. It's just basically creating like a high velocity air that is, or like a zone of air that basically like splits and shears the fuel or liquid droplets on each other from each other, and basically creates a very fine droplets, which are be easy and very like, I would say, yes, one, easy, second, have high enough to like easy to ignite, and have high enough surface area that we can have the combustion faster. That means that we can burn it through and burn it thoroughly, that we can burn the whole droplet thoroughly, rather than having half of it be evaporated by the heat in the combustion chamber, and either creating soot because the fuel is like unevenly when you have leftover fuel inside, that is going to one, evaporate, or second, it is going to be burned eventually, but because it is a rich zone in the inside, it is going to be burned kind of at once when it is getting like the size small enough that it has a high surface area compared to its volume. And then when it is fuel rich, there it basically creates a lot of soot and incomplete burn, because when you have low amount of air or oxidizer and high amount of fuel, which is the combustion material that you want to combust, that creates one, soot, all this debris, as well as like it probably creates like evaporates, and they call it volatile compounds, also non-volatile compounds. The non-volatile compounds are that's the soot. The other things are like CO, which is not too good if you have too low of a if you have the breach zone. Basically there is like, I'm going to bring it up, have this little good old, what do we call it, lambda, it's fuel air ratio, EFR, called it. All this fancy thing, here it is. They usually sign it with lambda. We can see here it's called stoichiometric ratio. Basically, here is the ideal in the between. This is called lambda 1, but this is, as you can see, fuel to air ratio. We need 14.7 parts of air to 1 part of fuel, which means that we need 14.7 like grams of air for 1 gram of fuel. No, this is not volumetric nor mass. This is molar. This is molar, meaning that we need 14.7 moles of air, which is not 14.7 times as much, but I think it is 14,000 times, yeah, 14,000. It needs a 3 zeros put behind it. 14, 1470. So 14,700 times as much, because we need, or not technically not that much, but like almost as much, because we can calculate the air with, we need 40 liters ish or 12 ish liters of air to 1 gram of fuel, which in terms of maybe that's correct, 14 points, but I don't think so, because we need like 14.7, we need like 12 liters, which is 12,000 millis, to a bit above 1.1 millis, because you know fuel is like 0.82 ish or point something like that, 0.85 if you're talking about these are 0.85 grams per milliliter, which is 890 or 820, 850 kilos per cubic meter 1000 liters. But as you can see here, that we need quite a lot of air. We need quite a lot of air so that we can burn the whole thing through. And the point was that we have this here, and as you can see, max power is basically given to us when we have a lower fuel ratio, but the lower fuel ratio is going to produce us more CO. The lower or like higher, so to speak, lower, wait a minute, air fuel ratio meaning that we burn it richer, not yes, we burn it richer, not, yes, as you can see it is even here, so I didn't read this. So yeah, we burn it richer than leaner, meaning that we have more fuel than air. If we have lesser air, we are going to, I think, increase the power definitely, but I think it is going to increase the, no, I don't think so. I think it is going to decrease the temperature, so we are going to have CO, which is the unburnt CO2. It is not full like the combustion is, when it is not like totally perfect, it is going to produce more CO2 than it should be. And that is not with a little, but with a lot. CO is like not too good to the environment, not to people, because it is like, you know, lethal if you inhale it, and it is also invisible, and like, it doesn't have any odor, so it's kind of disgusting, because you just drop dead, you know, it fucks with your blood, and then you're dead basically, just fall asleep and die. So not too lovely. Yeah, CO is not too good, and it jumps from like few ppm, like I think I have read about like 3-ish ppm, so per part per million CO with a industrial burner. It's like 3 or 4 ppm. This like a really low amount. With our I wouldn't say shitty, but like with our old in the school university, we have TKT1, which is the TS1, TS21, TS21, I think. Like output. '23, I'm sure. Here it is. So this is the TS21, or yeah, and we basically have about, I think it was 4, I can't remember, but it was a lot, I think. At high power it was like 500 parts per million, 475 570 or something like that, which is a fucking huge amount. So yeah, I think the side note ended printing out this part right now, but I'm not going to finish quite some time now. So what I'm going to do is I think I'm going to just I'm just going to read and then fucking bed down, pretty hammered, honestly. So we will continue tomorrow from here. We'll do some assembling and then do some wiring. I can't be bothered to do it right now. So yeah, thanks for watching. If you watch this back, then also my pleasure to have you here. So yeah, check out the other videos on that kind of bullshit. Subscribe. Cheers. I'm going to end it with this. So yeah, do the hard work, especially when you don't feel like it. You know what? Yeah, goodbye. Good night. Peace fingers out.